Welcome back to Physics for All YouTube channel. In today's session, I am going to explain you about Bravais lattices followed by simple cubic structure, body-centered cubic structure, face-centered cubic structure, and base-centered cubic structure. In order to understand Bravais lattices, first of all, we had discussed about some important definitions related to these structures. The first definition is nearest neighbor distance. All of you go through the definitions carefully. You take it as screenshot. These definitions are very important for the short answer questions. So, nearest neighbor distance. So, how can we define nearest neighbor distance? The distance from the centers of two atoms is called as nearest neighbor distance. It is generally denoted by A. Now, consider one atom. Okay. Now, it is another atom. Now, it is a center of the first atom. It is a center of the second atom. Now, the first atom and second atom are very close to each other. Very close to each other. So, from the center of the first atom to center of second atom, the distance is represented by using nearest neighbor distance denoted by small letter a anamata. Now here r is a radius of the first atom and r is a radius second atom. Now nearest neighbor distance can be calculated by using a is equal to r plus r, that is equal to r. So this is a nearest neighbor distance. Now coming to the second definition, that is atomic radius. So after getting equation for the nearest neighbor distance, how can we define atomic radius? Atomic radius is defined as the half of the nearest neighbor distance is known as atomic radius. It is generally represented by using R. Now coming to the third definition, coordination number. Now, as per the definition, the number of atoms nearer, and we have to check two conditions. The first condition is nearer, and second condition is equidistant. The number of atoms nearer and equidistant to other atom in a unit cell is known as coordination number. In order to understand about the coordination number, let us consider three atoms. First atom, one second. First atom, it is a second atom, and it is a third atom. In this diagram, three atoms are in contact with each other. Now, it is center of the first atom, second atom, and third atom. Now, this is the nearest neighbor distance, small a. And similarly, these two atoms are also nearest neighbors. Now, you go through the diagram carefully, you can understand the meaning of coordination number. So, as per the definition of coordination number, the number of atoms nearer and equidistant, that number is called as coordination number. Now, in this diagram, I have drawn three atoms, A atom, B atom, and C atom. Now, from the definition of nearest neighbor distance, from the central atom name is B. Okay. So, from the central atom B, from the central atom B, A is equidistant. That means distance between the A and B is equal to A, and distance between the B and C also is equal to A. That means with reference to the central atom, that is P atom, first atom and the third atom, both are nearer and both are equidistant. Therefore, coordination number for the central atom is equal to 2. That means for the central atom, that is B atom, two atoms are nearer to each other. At the same time, two atoms are equidistant to each other. So the coordination number for the central atom is number 2. That is the definition of coordination number. Then we'll go to the another definition, which is known as packing factor. It is also known as atomic packing factor, packing fraction, all are equal. Now, it is the ratio between volume of all atoms in a unit cell to the total volume of the unit cell, which is called as atomic packing fraction. Generally, this atomic packing fraction is calculated in terms of percentage. Now, the same definition can be expressed in equation. Atomic packing factor is equal to volume of total number of atoms in unit cell divided by the total volume of the unit cell. That equation can be rewritten as number of atoms per unit cell into volume of one atom after sharing divided by total number of total volume of the unit cell. Packing fraction is equal to, here n means total number of atoms after sharing into volume of each atom. Atom is in the shape of sphere. Therefore, here we are writing volume of a sphere 4 divided by 3 pi r cube. Now divided by total volume of the unit cell. Now in this example, we are assuming that the unit cell belongs to cubic crystal system. Already in the last class, we discussed about types of crystal systems. These systems are dividing into how many types? 7 types. That is known as cubic crystal system, tetragonal, rhombohedral, etc. This classification can be done by using lattice parameters of the unit cell. Now, in this calculation of packing fraction for the above said simple cubic structure, body-centered cubic structure, and face-centered cubic structure, we are assuming that unit cell belongs to cubic cell. Therefore, the case of cubic, length of x-axis is equal to length of y-axis is equal to length of z-axis is equal. That is, A is equal to B is equal to C. The place of B and C, I am taking A. So, A into A, that is equal to A power 3. So, using this formula, we can calculate packing fraction of any given structure. These are the important definitions based on the crystallography chapter. These definitions are important for the examination point of view. These questions can be asked in the university and examination in the section A, that is for the part A, for the 2 marks questions. Go through these definitions, and if you are having any doubt, please comment me in the comment section. We will discuss about the another topic, that is known as a simple cubic structure in the next coming session. All of you go through the slides carefully, and if you are having any doubt, please comment me in the comment section. Please subscribe my channel and like this channel, share to your friends in order to get the regular updates. Thank you for watching.